Hello students. Today in this session we are going to talk about the concept which we have left in the module 3. Okay, that is Cohen Sutherland line clipping algorithm. Okay, so yes, we have already discussed what is the clipping algorithm. Okay, and within that we have seen some set of types in the clipping algorithms. Yeah, instead of saying that clipping algorithms, I can say that the types of clipping. Okay, those were primitive clipping, line clipping, polygon clipping, text clipping, curve clippings. Okay, so in that we have already discussed what is the point clipping. Okay, and after that we have seen the line clipping. Okay, that was just introduction part. Okay, and after that we have seen polygon clipping algorithm. Okay, for this polygon clipping algorithm, we have used Sutherland Hodgman. Okay, polygon clipping. Okay, so in this session, we are going to talk this Cohen Sutherland line clipping algorithm. Okay, which is there in your third module. Okay, along with that, this algorithm is there in your lab program. Okay, so it will become um, easy for us. Okay, from the lab perspective and from the theory perspective, we can understand. Okay, with the help of code, OpenGL code. Okay, so Cohen and Sutherland, these are the two scientists who has invented this line clipping algorithm. Okay, so here this picture will gives a brief idea about what is this line clipping algorithm. Okay, so this is our clipping rectangle. Okay, or clipping window. Within that, okay, if we have a line, okay, a complete line, if the both the endpoints of the line is exactly placed within this clipping window, that line will be completely displayed. Okay, or we can say that that is completely accepted. Okay, if the particular line, okay, with when it's both the endpoints are outside and if it is not crossing the window, okay, then we can say that such lines will be rejected. Okay, that lines will not be displayed on our screen. Okay, similarly you can see for this line also both the endpoints are outside and this line is not at all passing through the clipping window, hence it will be completely rejected. Okay, what about this line? See here, this particular line, okay, here both the endpoints are outside the clipping window. Okay, but the line is passing through the clipping window, hence this line must be shortened. Okay, this line must be shortened. So in that, the whatever the line, okay, that is there outside the clipping window, that will be rejected. Okay, that will be scissored. Okay, similarly this place, okay, this point here also we are going to scissor. So wherever there is an intersection, okay, between this line and that clipping window, from that we are going to consider as a new point. From there onwards we are going to draw the line. Okay, so here also we got a new intersection for this particular line and this particular boundary. Okay, we got a new intersection point, so we are going to draw the line. Okay, so whatever was there outside, that will be clipped off. Okay, and the next one, in the next one we can see that one endpoint is inside, another point is outside. Okay, so here we will get a kind of intersection. Okay, so in that we will draw the inner part of the line. Okay, and outer part of the line will be rejected. Okay, I hope you can remember in the previous class I have said we have the 4 types of conditions whenever we are performing the line clipping. Okay, those are when both the endpoints of a given line is inside the clipping window, that line will be completely accepted. Okay, that was our first case. Second case says that when one of the endpoint is inside, another endpoint is outside, such line must be shortened. Okay, such line must be shortened. Okay, that is our second case. In the third case, if both the endpoints of a given line are outside and if the line is passing through or if the line is crossing the, if it is crossing the clipping window, okay, such line must be shortened. Okay, such line must be shortened. Okay, and in the final case, that is the fourth case, if both the endpoints of a given line are outside and the line is not at all not at all crossing the window, okay, such lines will be completely rejected. Okay, this is the basic concept of this Cohen Sutherland line clipping algorithm. Okay, now this line clipping algorithm is having some unique features. Okay, so here this clipping window, okay, here in this, whenever we have a window, within that we are going to make some regions, okay, and that regions we call it as a region codes or bit codes or out codes. Okay, so let me take this particular clipping window. Okay, this is our interested part. Okay, so here the first bit indicates, okay, the rightmost bit indicates it is a left bit. Okay, and the second one, that is our right bit, and the next one, third one, that is our bottom bit, and the first one, that is we call as a top bit. Hence we are going to use a kind of TBRL rule. Okay, TBRL rule. Okay, so let us understand how we are going to make this 9 region, okay, 9 region outcodes. Okay, so let me take this particular region. Okay, so am I in the see, first of all, I will start from here. Okay, am I in the left side? Yes, so I'm going to make that bit 1. Am I in the right side? No, so I will make it as a 0. The next one, am I in the bottom? Yes. Okay, so that I make it as a 1. Okay, am I in the top? No, so that I'm going to make it as a 0. Okay, so this is the region, okay, that we got. Similarly, I can perform for this one also. Am I in the left side? Yes. Am I in the bottom? No. Am I in the right? No. Okay, am I in the top? No. So all the bits will become 0. Okay, similarly for this region, I am in the left side. Okay, I am on the top side. Okay, so here 1001 will be the outcode region. Okay, so similarly, I hope you can perform for this operation, this region, this region, this region, and this region. What about this clipping part? Okay, clipping window. Here I am neither in the left side, I am neither on the right side, neither on the bottom, neither on the top side. Okay, so hence all the bits are become 0. Okay, so here we are using the 2-dimensional plane, hence we will get a 9 outcodes. Okay, we will get a 9 outcodes. If we are using, okay, 3-dimensional plane, okay, we will get a 27 outcodes. Okay, 27 outcodes. How? Because here we have only one plane, there we are going to use the near plane and far plane. Okay, so hence it will become 9 into 3. Okay, 9 into 3 means the 9 outcode region for the front, okay, 9 outcode region for the back, and 9 outcode region for the middle one. So totally 9 into 3, totally we will get a 27 outcodes, okay, for the 3-dimensional plane. Okay, so I hope you can recall there was a very strict formula, okay, whenever we are performing the clipping operation. That is, whenever we are taking the X, okay, for example, there is a line, okay, let's assume that there is a dot, okay. So dot, if it is there within this particular window, okay, this dot, okay, let me take it as a x comma y. Okay, so this x value, okay, with respect to the left and right, okay, so that we call it as a x min and x max respectively. So this x value should be greater than x min, right? And similarly, if the x value is less than x max, okay, then we can say that the x is within the left and right boundary. Okay, similarly, I can go for the y. Okay, the y, if the y value is greater than y min, okay, it is greater than y min and it is less than y max, okay, then we can say that y is also inside. When both the condition, when this x and y condition, when they are satisfied, then only we can say that the point, okay, that point is there within the clipping window. Okay, if any one of the condition fails, okay, then we can say that the line, that point has been discarded. Okay, so here, now this is the condition that we always follow. Okay, where whatever I have said, x is greater than x min, okay, and x is less than x max. Okay, similarly, y is greater than y min, okay, and y is less than y max. Okay, so see here, for the first bit, okay, 1, point lies to the left, okay, of the window, okay, when x is less than x min. Okay, if our x value is less than x min, okay, then we can say that our x is out, is coming in the outside the left boundary. Okay, it will come to the this part. Okay, similarly, that is the thing, but we make it as a 1. Okay, similarly, if the point lies, okay, in the right side, means if my point with respect to x value, if it is comes here, means x value is greater than x max, okay, this is our x max, okay, then we can say that it is exactly on the right side. So that part we will make it as a 1. See here, right part 1 1 1. For the left we have here 1 1 and 1, okay. Similarly, we can go for the bottom, okay. Whenever the y value is less than y min, okay. When the y value is less than y min, so that we will say that our y is exactly below to the this particular plane, okay, means this below boundary, okay. So when the y value is greater than y max, our y value is coming outside, okay. So whenever such conditions are happening, we will set their respective bit as 1, okay. But we are always interested our point, okay, lies within this clipping window so that we can display, okay. If the point lies outside this, we are going to reject, okay, we are not going to display that, okay. So here you can see that, okay. So this particular we are going to make, okay, this 4 boundaries, okay. This is the left boundary, right boundary, bottom boundary and top boundary, okay. So here this particular location we will take it as a x min y min, okay. Similarly this one x max y min, okay. And here x min y max, x max y max, okay. So assume this particular line, okay. So if I take this particular point x1 y1, this one has a x2 y2, yes, x1 is greater than x min, yes, true, okay. And x1 is less than x max, yes, that is also true. So with respect to x, okay, it is satisfied, okay. So there is no problem with respect to left and right side. Now with respect to y, okay, so y1 is greater than y min, yes. Y1 is less than y max, yes. So with respect to y, that is the bottom and top conditions also satisfied. Hence we can say that x1 is inside the clipping window, okay. Similarly we can perform for x2 and y2, okay. When this x1 y1 x2 y2 are completely inside the clipping window, okay, we are going to accept that, okay, we are going to accept that, okay. Similarly, we can go for this one. See here, this particular line is outside the clipping window, right? So it is partially inside, okay? Partially inside means both the endpoints are outside, but it is passing through the clipping window, okay? So hence, okay, such line must be shortened, okay? Because here you can see that the x value, it is satisfied, that is x1, okay? Let me assume that this is a x1. X1 is greater than x min, x is less than x max, okay. So that is a condition is satisfied with respect to x. But with respect to y, you can see that yes, y1 is greater than y min, but y1 is greater than y max, so there it is not satisfied, so it is coming outside, okay. So such line we have to shorten, okay. Similarly you can perform for this operation also. But what about this is completely outside, because it is not going to satisfy that condition, because x is less than x min here, okay, and x is less than x max, okay. And for this one and one more, so here with respect to y it is satisfying because y is greater than y min, y is less than y max, that condition is satisfied. But with respect to x it is not satisfying, okay. Similarly for this one also, so it is not satisfying, so hence we are going to reject this kind of lines, okay. But in the Cohen-Sutherland line clipping algorithm, we are not going to take the endpoints with the values. Okay, for example, if you are given the values for this line, okay, for example, 25, 25, 100, 100, okay, that type of values we are not going to take. Okay, here we will make the region, okay, that particular region, okay, we are going to convert that into outcodes. Okay, we are going to convert that into outcodes. So here, this complete clipping window, okay, we are going to make it as a, okay, out means that is outcodes. Okay, for example, if I am having here 25 comma 25, that we are going to convert it into outcodes. Okay, so it will become 0 0 0 0. Okay, similarly for this one, okay, it is also inside this clipping window, we will make it as a 0 0 0 0. Okay, how that we are going to see once we are starting the program. Okay, the next one, here once we convert, okay, this one in a outcode form, okay, so what is this one? This is a 0000, okay, just to follow this previous figure, okay, so 9 region, okay, outcodes are there, that would be reflected over here, okay, reflected over here. So now in this Cohen Sutherland line clipping algorithm, okay, we have 4 important steps, okay. So assume that completely inside the given clipping rectangle, okay, what we are going to do here, bitwise OR, okay, bitwise OR operation of the region of 2 endpoints of line is if it is become 0, okay, that is the thing. But if once I convert the values of this endpoint into the bit codes, okay, I will get 000, right? So here also I will get a 0000, okay. Once I will get their outcodes values, okay, I am performing the OR operation between these two, okay. Once I do the OR operation, again if I'm getting the 0 as a value, okay, 0 as a value, then we can say that both the endpoints are inside the rectangle, okay, both the points are inside the rectangle. This is the first case. Now completely outside the given rectangle, okay, so here both the endpoints share at least one outside region, which implies that the line does not cross the visible region, okay. What is the meaning of this one is, here when both the endpoints are outside the clipping rectangle, okay, both the regions are completely outside the clipping rectangle, okay. So what is the outcode for this one, okay, so that is thing but 0001, okay, 0001, okay. Similarly you can perform the, what is the outcode for this one? Yes, that is also in the same region, so 0001, okay. So whenever you perform the AND operation, okay, between these two, okay, if you are getting, okay, if you are getting 1, okay, which is not equal to 0, then we can say that it is completely outside, okay, it is completely outside. What is the second case? Okay, when both the endpoints are outside, okay, whenever we perform the AND operation on these two outcodes, if we are not getting the 0 value, if we are getting non-zero value, okay, then we can say that that complete line has been rejected, okay. The next one, third case. In the third case, partially inside the window, okay. What is the meaning of this one is, both the endpoints are in the different region. In this case, the algorithm finds one of the 2 point that is outside the rectangular region. The intersection of the line from the outside point and rectangular window becomes new corner point, and the algorithm repeats. What is the meaning of this one is, here when one of the endpoint is inside, another endpoint is outside, okay. So once we get the outcode of this one, and once we get the outcode of this one, okay, so once we get this one, wherever there is an intersection, okay, that intersection we have to find out, okay. Once the intersection we find out, okay, that particular line must be shortened, okay. So similarly, the same, this third case is also applicable for this condition also. That is, here both the endpoints are outside, but the line is crossing the clipping window, okay. So here we are going to shorten, okay, we are going to shorten this particular line, okay, and we will display only this much amount of line, and outside will be rejected, okay. So these are the 3 important cases that we should keep in our mind, okay, whenever we are making the program, okay. Now, let us go to the program. Okay. So in this program, okay, I have followed your CLM. Okay. So here, hash include std.h. Okay, for the, we have to use the input and output operation. So printf and scanf functions I'm going to use, because the user must specify, okay, the endpoints for your line, okay, endpoints for your clipping rectangle, for your window, okay. So next one, here we are going to use a kind of aliasing, that is the outcode of integer type, okay. Next one, x0, y0, x1, y1, that will be the variables for your lines, okay, endpoint for your lines. Similarly, xmin, ymin, xmax, ymax, this is our window, okay. Window means that is our the normal input window, okay. So next one, xv min, yv min, xv max, yv max. This is the window where we are going to see our output. Okay, so it is already predefined. okay, in our program. 200, 200, 300, 300. Okay, and next one, we are going to use, we are going to allocate the values, okay, for the left boundary. Left boundary, that is 0001. Yes, so we have used the TBRL rule. Okay, in that the left is always 1. We are not going to bother about top, right, and bottom. Okay, we will only focus on the left side. So what is the decimal value for this binary? That is nothing but 1. Okay, what about right? Okay, right is nothing but 0010. Okay, that's some TBRL. Okay, so R is 1 here. What is the decimal value for this one? That is a 2. Okay, similarly for the bottom, that is nothing but 4. Okay, and for the top it will become 8. Okay, I hope you understood how we have assigned this 1 2 4 8. Okay, now next one, as we know that the program will start from the main function. Okay, so here it is going to ask enter the endpoints for the clipping window. Okay, so here we are going to mention our clipping window. Okay, normally we are going to use some 50 50 100 100. Okay, and next one, some enter the endpoints for our line. Okay, so we will specify the line, and we are going to specify the line, and we will see that whether the this clipping operation can be done or not with the help of Cohen Sutherland line clipping algorithm. Okay, and next one is we are going to use the initialization function. Next, we are going to use the display mode. Okay, we are going to initialize all the buffers, that is a single buffer and RGB buffer. Then we are going to maintain the window size for our window, okay, of 500 500. Okay, if you want, you can change that one also. Okay, it is not a big issue. Okay, and next one, you are going to use the glut init window position, that is a 0 comma 0, that is a default position of your window. Okay, which is an optional. If you don't use this command in your program also, it is going to work. Okay, but the system will take the window position randomly. Okay, next one, you are going to specify the name for your window, that is Cohen Sutherland line clipping algorithm. Okay, it is just a textual form. Okay, you can give any name for it. Okay, but it should be appropriate for that program. Next one, we are going to use a callback function called glut display func. In that, we are going to use the display function. Okay, we will see what is the display function. Next one, we are going to use the my initialization function. Okay, it is a user defined function. In that, we are going to initialize the some of the commands. Okay, so normally we are going to initialize the viewing parameters. Okay, next one, we are going to use the glut main loop so that the particular program can be, it can execute in a loop. Okay, the main function should always execute in the loop form. Okay, unless and until there is any external, okay, signal from the user. Okay, once he click that close button, then only it will come out from the main loop. Okay, now what is that my initialization? My initialization is nothing but it is a user defined function. Okay, it is not recommended. Okay, in the program, wherever you want, you can write it. Okay, that is not a big issue. Okay, but in your CLM, you can see some unnecessary commands has been included. Okay, it is better that you can put the comment for that. Okay, so here we are going to use GL clear color. Okay, so this particular command will be used to clear the our buffer, okay, with a white color. Okay, so here it is a R, G, B, and the final one is, that is alpha. Okay, alpha is nothing but if it is a 1, it is a opaque, and if it is a 0, it is a transparent. Okay, so our window will be of white background. Okay, and it is opaque in nature. And next, we are going to use two-dimensional orthographic viewing. Okay, in which we are going to use left, right, bottom, and top. Okay, so it is of size 0 to 500, 0 to 500, which indicates that if this is the left part, okay, if this is the left part, this is the 0 0 500 0. Okay, 0 500 500 500. Okay, that is the size of our window. Okay, that is a viewing parameters. Okay, next one, display function. In the display function, we are going to clear the color buffer. Okay, with the which color? With the help of this particular command, GL clear color. Okay, so this GL clear color will be passed as a values to this particular color buffer bit. Okay, next one, we want to draw the line. Okay, and we want to draw the rectangle. Okay, so For that, the line we are going to use the red color, and for the rectangle we are going to use the blue color. Okay, so what is the meaning of this one is, see here, this is our input window. Okay, this is our input window and this is our input line. Okay, within the same window, here we are going to see the our output. Okay, this is the output window. Okay, and this is the clipped line. Okay, so here we are giving the input and here we are going to see the output. Okay, so we have passed the values for this one. Okay, see, it is of blue window and red line. Okay, yes, once you have used this draw line and draw rect, okay, what is the next job? We have to call this Cohen Sutherland line clip and draw. Okay, so for this clipping operation, okay, what is my input? The input is nothing but endpoint of my line. Okay, that is x0, y0, x1, y1. And finally, we are going to use the GL flush command. Okay, so to flush all the resultant values, okay, whichever is stored in the frame buffer, that will be displayed on your monitor. Okay, so this is the draw line function and draw rect function. In the draw line, we are going to use the primitive GL lines by taking the values from x0 and y0, x1, y1. Okay, similarly for the rectangle, we are going to use the primitive GL line group. In that x min, y min, x max, y min, x max, y max, x min, y max. I hope you have already studied this primitive. Okay, I'm not going to explain again. Now next one, outcode, compute outcode double x double y. Okay, what is the meaning of this one? So here initially, as I said, that whenever we pass the values, okay, that is x0, y0, x1, y1, okay, normally we will pass with some integer values, that is 25, 25, 100, 100, okay, 25, 100, 175. In that values we are going to specify. But here, what we are going to do here, we are going to convert that one into outcode form. Okay, we are going to convert that one into outcode form. Why? Because we are using the Cohen Sutherland line clipping algorithm, in which every region will be converted into outcode. So we are going to convert that one into a bit form. Okay, so here, first of all, let me take outcode, code is equals to 0. Okay, so I am assuming that now the outcode, the code value is completely 0. What is the outcode here? Outcode is nothing but integer form. Okay, so it is 0. I am assuming that I am completely inside the clipping window. Okay, next I am going to check if y is greater than y max. Okay, if y value is greater than y max. Okay, so what is going to happen? Okay, yes, so our point, that is y value, is above the clipping window. Okay, means it is above the top window. Okay, top boundary. Okay, so for such condition, what we are going to use, we are going to perform the OR operation, that is code equals to code or top. Okay, and whatever the value that we are going to use, that is we are going to store it in a code. Okay, next again we will check. Okay, next else, see here, else. Okay, else if y is less than y min, means it is exact, it is below to the bottom boundary. Okay, so we are going to use code equals to code or bottom. Okay, that value will be stored on the code. Okay, next one, if, see here, we are not going to use the else if here, we are going to use the separative. Okay, means there is a kind of dependency between these two statements. Okay, and there is no dependency between these two statements. Okay, this is completely for the top and bottom with respect to y, and this is for completely for right and left with respect to y. Okay, so if our x value is greater than x max, means our x value is in it is in the right side. Okay, what is the right value? Okay, so right is nothing but, I hope you can remember that the top, bottom, right and left, we have already used the values. Those were nothing but 1, 2, 4 and 8. Okay, that we have already used, but everything will be again converted into bit form. Okay, so here if it's x is greater than x max, code equals to code or right. Okay, or operation will be done. Else if x is less than x min, okay, code equals to code or left. Okay, and finally we are going to return the code with respect to the updated value of x and updated value of y. Okay, Now, let us go to this Cohen Sutherland line clip draw. Okay, so here we have passed that particular line. Okay, x0, y0, x1, y1. Okay, here it is better that if you take some values, for example, 25, 25, 75, 75. Okay, in that way you can take the values and you can analyze the program. So here outcode, okay, that is the integer, outcode 0, outcode 1, outcode out. Okay, what is this outcode 0? Outcode 0 is nothing but whenever you convert this x0 and y0 values in the outcode form, that will be stored it in a outcode 0. Okay, similarly this outcode 1 is used for this x1 and y1. Okay, once you perform the AND operation or OR operation between this outcode 0 and outcode 1, whatever the result that you're going to get, that will be stored it in a outcode out. Okay, initially we are going to keep accept is equals to false, done is equals to false, means we not at all accepted, we not at all done the clipping operation. Okay, now outcode 0 equals to compute outcode x0 comma y0. Okay, so here we are passing the x0 y0 values. Okay, that is passed to the compute outcode. Okay, it will come to the compute outcode function. Okay, so here it is going to perform this particular operation. Okay, next one that will be stored in a outcode 0. Okay, and next one similarly you are going to perform the outcode out, compute outcode for the x1 y1, that will be stored in the outcode 1. Okay, next do operation. Okay, in the do operation, if not, okay, not operation, outcode 0 or outcode 1. Okay, if you are doing the OR operation on these two, okay, and not, okay, not means whenever you perform the outcode 0 and 0, we assume that this is a 0, outcode 0 value is having the 0, outcode 1 is also having the value 0. Okay, 0 or 0, you will get 0. Okay, it's not means it is nothing but it is completely accepted. So it is dealing on our first case. That is, it is dealing on our first case, means the particular line and its endpoint is completely inside the clipping rectangle, hence it will be completely accepted. Okay, so it is accepted and it is done true. Okay, next else means we are going to use the remaining cases. Okay, that is one endpoint is inside, another endpoint is outside. Okay, or otherwise both the endpoints are outside. Okay, and it is crossing the window. Okay, and one more case, both the endpoints are outside and it is not at all crossing the window. Okay, such lines will be rejected, that we are going to see here. Else if, okay, outcode 0 and outcode 1, okay, done equals to true. Okay, what is the meaning of this one is whenever you perform outcode 0 and outcode 1, okay, if the AND operation gives you value 1, which indicates that that particular line is completely outside. Okay, so it is done. Okay, done means what? Here we will come to know that that particular line is completely outside. Okay, except is not at all, we are not going to update any except. Okay, why? Because we are not going to include that one within our clipping window. Okay, because that is completely outside, so we are not going to use the except. We will feel that we are just going to use the done is equals to true. Okay, that is the end. Okay, we are not going to process that particular line. Okay, whichever is there completely outside. The next one else. Here this is very tricky part. Here one endpoint is inside, another endpoint is outside, otherwise both the endpoints are outside but the line is passing through the window. At that stage we are going to use the outcode out equals to outcode 0 ternary operator. Okay, outcode 0 uh, outcode 0 colon outcode 1. Okay, so based upon the values, okay, it is going to select, okay, what will be the value for outcode 0. Okay, it may be either outcode 0 or outcode 1. Next one, so if our outcode out is top, okay, we are going to perform the AND operation on it. Okay, we are going to get this particular equation. Okay, similarly for the bottom, okay, with the outcode, when we perform the AND operation, we will get this equation. Similarly for right, similarly for the bottom. Okay, how I got this equation? Okay, let us see the top. Okay, but before this we should know this particular equation of a line, that is a y equals to mx plus b, okay, or y equals to mx plus c. Okay, so if this is the top boundary, okay, if this is my line, okay, you see this is x0 y0 and this is x1 y1. So here the intersection can be observed, okay, that is nothing but x comma y. Okay, so this is our x min y min, sorry, x min y max, x max y max. So with respect to the y, okay, we have the common y value, that is nothing but y equals to y max. Okay, what about the x? Okay, x is nothing but just interchange this particular equation. Okay, just interchange this particular equation. Okay, what we will get, so here what is the slope? Slope is nothing but x1, okay, x1 minus x0, x1 minus x0 minus y1 minus y0. Okay, that is the our slope. Okay, and multiplied with the y. What is the y? Y is nothing but y max minus y naught, this much distance. Okay, so that is our x value. Okay, similarly you can go for the bottom. In the bottom, y min is constant, hence the particular intersected point where the y value will become y min, and x is equals to x naught plus x1 minus x naught, y1 minus y naught. The slope will remain same. Okay, but here instead of y max minus y naught, we are going to get a y min minus y naught. Okay, just if you remember one point, you can easily understand the second point. Okay, just you have to analyze this part. Next one for the right. Okay, in the right, okay, this is the right boundary. Okay, x0 y0, x1 y1, and this is the intersection. Okay, what is the x value? X value is nothing but x max only, right? What is the y value? Y is equals to mx plus c. Okay, so here y0 is nothing but intercept. Okay, similarly here x0 and x0, they are intercept. Okay, so here what is the slope? Slope is nothing but y1 minus y0 divided by x1 minus x0. Okay, into x min minus, sorry, x max minus x naught. Okay, x max minus x naught, this particular distance. What about left? X is equals to x min, y equals to y naught plus y1 minus y naught divided by x1 minus x naught into x min minus x naught. Okay, so same thing. Okay, but for the right, x will become x max. For left, x equals to x min. Okay, and remaining things will be same. Okay, and here x max minus x naught, here x min minus x naught. Okay, so this is the equation that I have used in our program. Okay, next one. Okay, with the continuation of that program. Okay, that is nothing but this one. Okay, so thus if outcode out is equals to that of outcode 0, what we are going to use, that whatever means here outcode out, whatever the computed value that I got, if it is equals to outcode 0 means, for example, for that x naught and y naught, what I am going to use, that values, the new updated values of x and y, that I am going to apply to the x naught and y naught. Okay, that values I am going to store it to the x naught and y naught. Okay, means I'm going to rename now. Okay, so assume that here this is the condition. Okay, okay, let me take this condition. Okay, so here x and y is there. Okay, but anyhow it is inside, but this is outside, right? So once the scissoring has been done, okay, now I'm going to forget this one and I'm going to remember this one. So here I'm going to use as a x1 and y1. Okay, similarly in the program we have taken as a x0 and y0. Okay, else we can use the x1 y1. Okay, it depends. Okay, which endpoint is outside, which endpoint is inside. Okay, as we know, because sometimes x0 y0 may be outside, or sometimes x0 y0 may be inside. Okay, anything can happen. Okay, so this condition will be performed unless and until it is accepted. Okay, okay, once it is accepted, we are going to use this scaling operation. Scaling operation is nothing but here we are going to maintain the aspect ratio. Okay, that is nothing but xv max minus xv min divided by x max minus x min. Okay, means for this particular output window, okay, its ratio with respect to x-axis whole divided by, okay, our input window, its x-axis ratio, okay, x-axis value. Okay, together we are going to divide. Okay, and we are get a kind of ratio. Okay, so that is going to maintain the proportionality. Okay, so similarly we can perform for the y also. Okay, once we perform this one, we have the new Vx0, Vy0, Vx1, Vy1. Okay, this is the variables for our clipped line. Okay, previously we have used x0, y0, x1, y1 for our line. So here we are going to use a Vx0, Vy0, Vx1, Vy1. Okay, so here we have performed the scaling operation, okay, as well as the translation operation. Okay, why means once we have done this one, this is the input. Okay, okay, whenever we want to depict, okay, the output in this particular window, okay, we have to maintain the proportionality of this particular line, right? Okay, so for that we are going to use these equations. Okay, so if you take some values, okay, and if you follow these procedures, okay, if you analyze, you can understand the point. Okay, and finally, okay, we will use the color, that is a red color. Okay, and we are going to use the primitive, okay, line loop, so that we can draw this particular output window. Okay, so similarly, we are going to use this lines, okay, Vx0, Vy0, Vx1, Vy1 to draw this particular line. Okay, so you can see in the output, we have specified 50, 50, 100, 100. Okay, means 50, 50, 100, 100. This is the, this is the endpoints for our window. Okay, 50, 50, 100, 100. Okay, what about the line? The line here is 30, 30, 120, 120. Okay, so once we specify like this, okay, we will get the output line like this. Okay, so this is your Cohen Sutherland line clipping algorithm. Okay, thank you.